Good morning, everybody. Have you all joined? Good morning, Monica. Are you able to hear me? Good morning, Shivangi. Are you able to hear me? Good morning, everyone. Welcome to this course, Introductory Astronomy. So I'll wait for 1 or 2 minutes so that all can join the online lecture. Very good. Once again, good morning to everyone. I have started the unit 2 of this course instead of unit 1 for a very good reason, which would be clear in a moment. All right, so I'll start the first lecture. Now, the reason I started with the unit 2 instead of unit 1 is to pay tribute to one of the outstanding astronomers of India, Professor Govind Swarup. Professor Govind Swarup is known to everyone as the father of radio astronomy in India. You can see a picture on the right when Govind Swarup was young with his wife. And Govind Swarup, he was a phenomenal scientist who in 1960s, with limited resources, with the help of Tata Institute of Fundamental Research, where he was a faculty member, he built the Uti radio telescope in the hills of Utkamand in Tamil Nadu. And the entire work was completely indigenous. He collected a team of excellent astronomers and engineers, and they set up a grand telescope that reclined on the slopes of a hill at Uti. And the reason I have began with Professor Govind Swarup is, unfortunately, Professor Swarup is no longer with us. He breathed his last in this month on September 7th this year. And it is a very sad event for the entire country that a phenomenal radio astronomer who established not only the Uti radio telescope, but the giant meter radio telescopes of Tata Institute of Fundamental Research near Khodad in Maharashtra. And anyone who has visited the GMRT site would be certainly astonished to see the huge radio dishes in a Y-shaped array of many radio dishes, and it has been doing outstanding work in detecting pulsars, detecting 21 centimeter lines from neutral hydrogen clouds, etc. So I begin the introductory astronomy course by paying tribute to this phenomenal scientist, Professor Govind Swarup, and my deepest condolences to all his family members. Right. Now let me flash you a picture of the Uti radio telescope. As you can see, the Uti radio telescope is essentially a cylindrical paraboloid which is on a slope. And the reason why Professor Swarup selected this site is that the angle of the slope is such that the axis of this cylindrical paraboloid radio telescope is parallel to the axis of Earth. Now, why did Professor Swarup choose such a site? The reason was that in order to scan the cosmos, you don't have to do too much of additional work in steering the radio telescope, but as the Earth rotates, naturally the radio telescope of Uti would scan a large part of the sky naturally and would be able to detect fascinating and mysterious radio sources. Right. Let us go ahead with the course. Since this course is an open elective, I'm sure that there are students who have credited the course who are from outside the Department of Physics and Astronomy. And since the sky is for everyone to gaze at, I'm sure all of you, sometime or other, would have stared at the night sky from a place where the pollution and particularly the light pollution of megacities don't obstruct our views to the grandeur of the night sky. Now, this slide shows a part of the night sky where you can see the Orion constellation. This is the Orion constellation. There's a belt of a so-called imagined man who is facing the Taurus, the bull, in an aggressive manner. As you can see, the right shoulder is lifted up as though confronting Taurus, the bull, and this is the belt of the Orion warrior, and these are the legs. You can see the left leg and the right leg. And just below the right leg, you can see these prominent 5 stars. This is the Sirius constellation. The Sirius constellation was viewed to be a dog who is associated with Orion the hunter. In many parts of India, like in Maharashtra, Orion is referred to as Vyad, Vyad or hunter, because usually in old times, hunter always was accompanied by a hunting dog. So Sirius, the hunting dog, the Orion constellation as a cosmic hunter. Of course, these are all imagination of our ancestors. First of all, we only see objects of our cosmos projected on the sky. So, although in the two-dimensional sky, these stars appear to be grouped. So, the Orion constellation is a group of stars which seem to give an impression of a warrior, but these stars may not be physically linked to each other at all because they might be very far from each other. It is only the projected position on the two-dimensional sky that gives the appearance that these are grouped together. And so is about any constellation like Sirius or Scorpio or Leo and so on. Our ancestors, when they gazed at the night sky and saw these stars, the natural human imagination automatically made them think as though they are figures related to the day-to-day experiences of human beings. So either some constellation reminded them of human figures or of animals and so on. And the use of imagination to describe the stars and the constellations on the night sky is not very surprising. After all, project yourself to times that are 4,000 years ago. We are talking about times corresponding to the dawn of human civilization. Around 2000 BC, the Indus Valley civilization was thriving in a very active manner, and so was Mesopotamian civilization, Chinese civilization, Egyptian civilization, and so on. And everyone knows that these great civilizations were river-based civilization. Thereby, what I mean is that these civilizations sprang up near powerful rivers. Like Indus Valley civilization was essentially thriving because of the Nile River. Similarly, Mesopotamian civilization was taking advantage of Tigris and Euphrates. Our very own Indus Valley civilization, whose inhabitants remain to us mysterious, their language remain to us mysterious because no one yet has been able to decipher the Indus script. And surprisingly enough, the Brahui community, which is in the northwest of India, their language is very similar to the Dravidian languages, namely Tamil. So many historians believe that probably the language spoken by the Indus Valley people were an archaic form of Tamil, the reason being the Brahui community was in the same region. So perhaps a part of the Indus Valley language still survives among the Brahui community who are in the in near the Baluchistan region. Indus Valley civilization, of course, thrived near the river of Sindhu. Sindhu became Hindu as it went to the lexicon of Persians and Arabs, and then by the time it reached the West, namely Greeks, Sindhu turning to Hindu in Persia became Hindu. So Indus, and that's how uh, the name of India came from essentially the river Sindhu. And Sindhu River was the one which caused the Indus Valley civilization. Those who are from the discipline of biological sciences, I leave a question for you. And what is the question? We all know that human beings are endowed with the skill of imagination. Of course, we don't know whether other intelligent animals like dolphin, chimpanzee, gorillas, whether they imagine. Probably in some limited form, they too have imagination. But certainly, we human beings, we time to time, we indulge in our flights of imagination and we imagine all kinds of strange things. For instance, I can obviously imagine that I am able to fly on my own and go beyond the atmosphere and take a survey of the earth, go to moon on my own without any spaceship, just fly into the space and hop from the solar system to exoplanets which are being discovered near other stars and so on. But of course, no one would believe me. Even I don't believe myself because, after all, these are all a figment of my imagination. But the question would still remain as to what advantage did imagination give to human beings? After all, Darwinian evolution tells us that many of our talents and skills were encouraged from one ancestor to another ancestor for the sake of survival. So we know that human beings, as they don't have much of a physical defense parts, unlike animals who could have thick hides, claws to defend, big and sharp teeth to fight off predators or to prey on other animals, human beings relatively are physically weak. But yet, human beings survived because of intelligence. They could use their intelligence to figure out whether there are predators nearby or how to use tools to break hard stuff, how to use water and plow to irrigate fields and grow grains for their own survival, and so on. So, intelligence certainly helped human beings to survive. And therefore, the question to my biological sciences friends is that the fact that human beings are endowed with the talent of imagining, imagination must have also played a big role in the survival. Of course, one hint comes straight away, and that is imagination is often used to plan before undertaking any exploration. We must uh, realize that human beings have also been great explorers, and that's how uh, people from different regions, they migrate in search of various things, whether it is food, gold, precious gems. They explore other regions. They explore regions not only for material goods but also to satisfy the thirst for knowledge and so on. But before a group starts exploring, they are taken up by imagination. So when Columbus initiated his expedition, he was certainly inspired by the imagination of reaching the land of India, which was fabled to have gold and spices and so on. It is another matter that Columbus did not reach India but reached North America, and another history was made, but that's a separate matter. So, certainly, imagination plays a role in the beginning phase of exploration, but things like poetic imagination or imagination that science fiction authors indulge in, or the imagination which is involved in fairy tales or mythologies, etc., these imagination must have also played role in human survival. Maybe imagination played a role in the form of grandparents telling children stories inside their caves, and that's how knowledge got transferred from elders to the younger generation and so on. Maybe this is also another important role of imagination. Now, you might wonder, why am I talking about imagination in the context of astronomy? The reason is that the night sky and the stars and constellation played a great role in shaping up the collective memories of early human beings. Just like in this example of Orion facing the bull and Sirius following the Orion, a story was created. And early part of proto-astronomy was essentially filled with stories related to stars and constellations. Let's move forward. Another great astronomical event which were certainly witnessed by our ancestors in all parts of the world are solar eclipse and lunar eclipse. I'm sure all of you at some point or other would have seen either a lunar eclipse or, using proper precaution, would have witnessed a solar eclipse. Now, obviously, these events, because they are rare and create a very different atmosphere when they occur, they grasp one's imagination. Now, you would be surprised to know that in the context of India, one of the early references to solar eclipse is in Rig Veda. There is a shloka or hymn attributed to the Atri family. Atri was a well known rishi associated with many of the shloka or hymns of Rig Veda. And there is a shloka attributed either directly to Atri or his clan. And in the shloka, Atri says that Surya or the sun was afflicted by a demon whose name was Swarabhanu. And because of Swarabhanu, Surya or sun was afflicted and not in his uh, true glory, because Swarabhanu had shot arrows at sun and caused either dark spots or attrition of a large part of sun. And then Atri mentions in the shloka or the hymn that he chanted a mantra, and after his chanting of the mantra, sun came back to his own full glory, and no more was he afflicted by the wounds caused by the demon Saurabhanu. Anyone who reads the shloka obviously would infer that this refers to a solar eclipse event whereby, as time progresses, when moon starts coming between the sun and the earth, we apparently see that portions of the sun is getting eaten away, and in a total eclipse, after some time, the entire sun disappears for a brief time, and then again it emerges slowly, because after all, moon keeps rotating around the earth. Now, Saurabhanu, one would speculate, later on turned into the demon Rahu, because the word Bhanu doesn't sound very different from the word Rahu. The syllables are right, but because in the Vedic tradition things were orally transmitted and people essentially memorized, so when things were transmitted from one person to another person, there would be changes, and perhaps the reason why Rahu and Ketu were later on associated with the solar and lunar eclipses were because Saurabhanu, the name, got corrupted to Rahu. My own speculation is the word Hanu of Hanuman might have also come from Bhanu. Now, why am I saying that? Anyone who has read Valmiki Ramayana and the Kiskindha Kand of Valmiki Ramayana might have read the story of how Hanuman was born. So, Hanuman in the Ramayana epic, in the story, was born to Anjana, his mother, and Pavana or Marut, one of the Rigvedic gods, Marut, or the so-called wind god, Pavana. And in the story of Kiskinda Kand, as soon as Hanuman was born, the little baby Hanuman, he saw the sun rising, and the orangish red sun rising at the horizon gave the appearance of a very delicious fruit to baby Hanuman. And baby Hanuman was sort of attracted by this beautiful fruit, and he wanted to eat it. So baby Hanuman leapt towards the rising sun, and he wanted to eat this reddish orange fruit. And when sun saw the approaching baby Hanuman, he immediately prayed to Indra, the god of the gods, to rescue him. And then there is the whole story about Indra and other gods fighting with the baby Hanuman. Now, that the story is about a little Hanuman trying to eat sun, eat the cosmic object sun, is essentially very close to Swarabhanu causing wounds to the sun in the shloka that is found in Rig Veda. Of course, these are speculations, they cannot be proved because these are Rig Veda itself is almost 4,000 years old, and Ramayana certainly is at least 3,000 or 2,800 years old. So, how all these descriptions emerged out of the minds of poetic rishis, we can't be sure. We can only speculate. And that is the reason why I said that the proto-astronomy goes in hand with human imagination. Let's go ahead. Let us now look at when was the first proper understanding of solar and lunar eclipse occur. And here we will have to refer to one of the greatest astronomer mathematicians of all times, who was born in India, namely Aryabhatta. Aryabhatta, around 470 AD, that was the time of Gupta period, and historians believe that Aryabhatta was one of the Navaratnas of the Gupta period kings, and one cannot be sure whether it is Samudragupta or Skandagupta. But Aryabhatta is associated with the Gupta dynasty, and Aryabhatta was a brilliant mathematician cum astronomer. He understood the actual cause of solar and lunar eclipses. Here I must tell you that before Aryabhatta, as I said, the poetic imaginations of people like Valmiki, Vyasa, and many other sages had also tried to explain solar and lunar eclipse in mythological terms. For example, all of you know the mythological story associated with Rahu, Ketu, and the eclipses of sun and moon. If not, let me briefly mention the story. As you know, uh, in Puranas, there is a story of Samudra Manthan. Samudra Manthan is essentially about trying to extract Amrita, or the so called ambrosia, the nectar that brings immortality. Samudra Manthan was about extracting Amrita by churning the ocean. And uh, because gods realized churning the ocean cannot be uh, attained only by the gods, and therefore they had to take the help of asuras. So both devas and asuras, they churn the ocean, and many things come out of the cosmic churning, including Amrita or ambrosia. And when the Amrita comes out, it is stored in uh, various jars. Gods wanted the jars filled with Amrita to themselves, and that's the reason why Asura decided that they must steal the Amrita, and they send a demon, Rahu. And Rahu comes to one of the jars containing Amrita, and before taking the jar away, Rahu also drinks some amount of Amrita. But sun and the moon, they spot Rahu drinking Amrita, and they immediately uh, notify the other gods. And when Rahu with the jar of Amrita is trying to escape, Vishnu with his Sudarshan Chakra cuts Rahu into two pieces. The head part is called Rahu, the tail, which is like a serpent's tail, a snake like tail, is called Ketu. And later on, because the Ketu was the tail part of Rahu, later on in Sanskrit sources, Ketu also started being used for comets, like Dhumketu. So comets got the epithet Ketu because of the tail-like shape of the Rahu Ketu uh, demon. Of course, the Rahu Ketu demon is just a story, but nevertheless, uh, in the Puranic literature, therefore, since Rahu was the head and Ketu was the tail, and Rahu obviously wanted to take revenge on Surya and Chandra, because they were the ones who alerted the other gods about his stealing Amrita, and hence Rahu time to time takes revenge by trying to swallow sun, but it can't retain sun for a long time because it only has a head, and therefore it swallows the sun and there is eclipse. But because Rahu doesn't have the body, sun comes out of the throat once again. And similarly, lunar eclipse happens when Rahu tries to swallow moon. But Aryabhatta, being a genius mathematician and astronomer, he wanted to know the real scientific reason for the solar and lunar eclipse. And because he was also a very good observer, he had in fact made some implements to do trigonometric analysis of positions of planets and so on. And Aryabhatta, through his research, had also come to the conclusion that the orbit, the Earth-Sun orbit, the plane containing the Earth-Sun orbit was different from the plane of Moon's orbit around Earth. So please refer to the diagram. So here you can see that Earth is going around the Sun. Of course, this is a modern outlook, but never mind. I mean, we are after all trying to understand the current interpretation of solar and lunar eclipse. So here is Sun, Earth is going around, all right, and Moon is going around the Earth, but Moon's plane in which it is going around Earth is tilted with respect to the Earth-Sun orbital plane. So this is the Earth-Sun orbital plane, while Moon going around the Earth, that plane is has a tilt. We all know from our simple geometry that we have been learning from our school days, if two planes are non-coplanar, that means if two planes are not parallel to themselves, then non-coplanar planes, they intersect on a line. Okay, so the orbital plane of Moon intersects the Earth-Sun orbital plane along a line. So Moon is, let's say, going in this direction. So the Moon is going around Earth in this manner. Aryabhatta called the point of intersection between the ecliptic is nothing but the Earth-Sun plane, and the Moon's orbital plane. So when Moon is going up like this, the point where this intersection occurs, namely the ascending node, Aryabhatta called the ascending node as Rahu. Then Moon, as it goes around, at some point it comes down and it intersects with the Earth-Sun plane. So therefore, when it is coming down or descending, the point where it intersects is called the descending node, and it was called as Ketu. Why did Aryabhatta and the other Siddhantic astronomers like Varahamihira, Brahmagupta called these 2 points as Rahu and Ketu? There's a reason. Note that, let's say, Earth is here, Sun is here, okay, and the Moon is going around this orbit. Now, not all the time when Moon is here, Earth is here, and Sun is here, you will find eclipse. Why? Because Earth is here, but the Moon is here and Sun is here. So Earth doesn't come between the Moon and the Sun. Only when the Moon is here, this line is where Earth comes here, Moon is here, and then Earth comes between Moon and Sun, and then from Earth you can see lunar eclipse. Similarly, when Moon comes here, Earth is here, then you see the solar eclipse, because now Moon has come between Earth and Sun. So in other words, only when Sun Earth Moon is along the line joining the two nodes, Rahu and Ketu, would one see solar or lunar eclipses? Not that's the reason why not all full moon nights are lunar eclipse, or not all new moon nights, new moon days are solar eclipses. In other words, the reason why full moon and new moon they occur every month, but solar eclipse and lunar eclipse are much rarer. The reason is that only when position of moon is along this line joining Rahu and Ketu, only then you can have either solar eclipse or lunar eclipse, depending on whether moon comes between earth and sun, or whether earth comes between uh, earth and moon. All right. And Aryabhatta was the first Indian to have understood the full mechanism of solar and lunar eclipses, and it appeared in Aryabhatiya in around 474 AD. Now, here I must, to be historically accurate, must mention that before Aryabhatta, a Greek astronomer Hipparchus had also understood the real reason of solar and lunar eclipses. All right, let us go ahead. Since we are talking about moon, we all know, I'm sure many of you would have looked at the moon at its various phases from a place where the sky is very nice. But I'm sure all of you would have noticed that if you take moon showing it's one of its phase, like this slide where you have a crescent moon, and all of you would have noticed that yes, the crescent part of the moon is bright, no doubt, but you could see a faint outline of the other part of the sphere. It is somewhat brighter than the night sky. Crescent moon, of course, is very bright. Why is it very bright? Because sun is in this direction. So it's the sun's light that is coming from this direction, falling on this part of the hemisphere of the moon and getting scattered. And the scattered light is what we are observing, and we think that it is this part of the moon which is radiating the light, but actually it is only scattering the light that is falling on the surface, the light which is coming from the sun. And from the geometry of the crescent moon, you can immediately figure out which direction is sun. You can immediately figure out the sun is somewhere. Sun, of course, has already set, but sun must be in this direction. But the opposite part, it is dark, no doubt, but it is not as dark as the background night sky. It's somewhat brighter. Now, this was commented upon by Galileo, because Galileo, he was the first scientist to put telescope into use to study heavenly objects. Many historians believe that telescope was actually invented in the Persian world or the Arab world, but Galileo was the first one to use telescope to study cosmic objects. And Galileo certainly wondered about why is the dark part of the moon not as dark as the background night sky. Today we know why it is so. I leave it to you to figure out why the dark part of the moon is not as dark as the background night sky. So please find it out yourself. Why is that so? But let me ask you one question. Those who have interest in history, they can also try to find out whether this particular aspect has been mentioned in either Vedic literature or our epics. To be precise, what I'm asking is that some of you might also try to do a little bit of research to find out whether our Vedic literature, whether it is Rig Veda, Atharva Veda, Samaveda, Yajurveda, or epics like Mahabharata, Ramayana, whether this aspect of moon is mentioned, that there is a bright part of moon, of course, but the dark part is not as dark as the night sky. I'll be very happy to know if there is a reference to this in our uh, old literature. It may not be just Sanskrit literature, it could be also the old Dravidian literature. As you know, that the old Tamil literature is also very ancient. The so called Sangama literature traces the poetic gatherings of people from the Dravid region, southern region, and so therefore uh, students who are familiar with the Sangam literature can also try to figure out whether the Sangam literature of 200 BC, do they find reference to this feature that the dark part of the moon is brighter than the night sky. I will only leave you with this uh, uh, statement in a book called And the Mountains Echoed. It's a lovely book written by Khaled Hosseini. In that, there is a line which I liked it very much, and that's the reason why I put it in the slide. The line is: a delicate crescent moon cradled the dim, ghostly outline of its full shape. So the 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 so-called dark part, which is not as dark as the night sky, has been referred as the dim, ghostly outline of its full self. Okay, so let us move ahead. We will still stick to moon. Now, moon, it goes around Earth, of course, and that is the reason why we see various phases of moon. In fact, Indian calendar, although it is a combination of lunar and solar calendar, but largely the months in India essentially uh, are categorized in terms of the lunar period around Earth. But moon also spins about its own axis. Just like Earth not only goes around sun, but it also spins around its own axis. And that's the reason why we have day and night. Similarly, moon too spins around its own axis. But the surprising thing is the spin period of our moon is same as the orbital period of the moon around Earth. To be more precise, we all know that moon goes around the earth in about 28 days, roughly 28 days. But moon also spins around its own axis with a period of roughly 28 days. How can someone through observation figure out that what I have said just right now is correct? This can be corroborated observationally by monitoring the moon every night over a full month, and you can, by monitoring the moon, you can see that we are seeing the same face of the moon every night. So by monitoring the moon for about 28 days using a telescope, you can figure out that we are seeing the same face of the moon every time. This can happen only if the spin period of the moon is same as the orbital period of moon around earth. Why? This slide gives a detailed thing. Supposing I am looking at the moon from this position. So look at this arrow. So arrow is pointing towards me. Earth-based human being is seeing moon and the arrow is pointing towards him. But the fact that we are seeing the same face, meaning when the moon comes here and a human being sees the moon, the arrow is also, same arrow is pointing towards the human being. That means this arrow's direction now has changed to this. Similarly, when the moon comes here, the arrow is still pointing towards a human being on the earth. Similarly here, and it comes back to the same position. That means the direction of the arrow has rotated by full 360 degree when the moon itself has completed a full 360 degree. This can happen only if the arrow is also rotating with the same period as moon's going around the Earth. In other words, moon is spinning with the same period as its orbital motion. Obviously, you must wonder that why should this happen? Why is it that moon's spin period is same as the period of moon orbital motion around Earth? The real reason comes from Newtonian gravity. So some other time when I have covered a little bit of Newtonian gravity and the tidal force, I will explain why is it that today the moon's spin motion and the orbital motion are locked to each other. It's called the tidal locking. It happens because of the tidal forces of Earth on moon. We all know that the tidal force due to moon and the sun causes the high tide and the low tide of our ocean. But the spin period of moon being synchronized with its orbital period happens because of Earth's tidal force on moon. All right, so I think I will take a short break. It is now 11. I'll take a short break. What I would urge is in this break, you can think of questions and write it to me. If you have any doubt or question, you can write. So we'll have a short break.
Further questions, they could actually be added onto this session itself. If we end this broadcast, we will have to give a new link for the students to come back in.
No, no, we are not ending. We are
Yeah, will
just
not. Yes, yes. The
will
questions
not close.
will come in. There were several questions earlier too. So a few questions were there, a few comments and questions were there. So perhaps after the break we could put up the questions first. Any questions students have, could they could put it in the chat form right now. After the break they can be taken up. During this time, if there are any questions, they can be typed on YouTube, and they can be flashed into the presentation, and they can be taken up after the break.
All right, shall we begin again? Okay. Yeah, so let me first answer a question of Dinesh. Sun too rotates, but Sun's rotation is differential rotation. Unlike Earth, Sun is a gaseous body, and therefore different parts of the Sun rotate differentially. Okay, so in fact, Sun is spinning too. Not only Sun is spinning, but Sun is also going around the center of our galaxy. So all objects in the cosmos, they move. All right, so let's go back to the slide. The phases of the moon are essentially due to moon's rotation around the earth. So this slide shows when will you have new moon, when the full moon. Remember the fact that moon's orbital plane around earth is at an angle to the sun earth plane, and therefore when moon as it is going around sun is in this position, although in this two-dimensional picture you feel that in this moon is in the same line as sun and earth, but remember this plane is inclined, so therefore actually moon is above the plane and therefore there's no eclipse. But because the moon is above the plane and the bright part of the moon is facing sun, we only see the dark part of the moon, and that's why it's called Amavasya or new moon. While when the moon is in this position, remember if this is up, moon is down, and therefore again sun, earth and moon are not in the same line, and therefore this part of the moon is getting entire sun light and therefore it is fully illuminated, and that's why we call it full moon or Jyotsna, the Purnima, Jyotsna from the Purnima night. And at different position, therefore, you see different phases of moon. In other words, the phases of the moon appears only because of the motion of moon around the earth. And again, to highlight the point, not all new moon days are solar eclipse, not all full moon days are lunar eclipse. As Aryabhatta had realized, only if this direction is the line connecting the two nodes, which he called Rahu and Ketu, only then there would be solar eclipse or lunar eclipse. Okay. Let's go to the next slide. Right. The other point which is of interest and which our ancestors knew very well is that as you keep watching stars, so supposing you take a camera and keep the shutter open for the entire night and point to the night sky, what will you see? You will see that as the night progresses, the apparent position of a particular star will go around like this. The apparent position of Every star will change as the night progresses, but there will be one star whose position remains the same. What do we call that star? We call that star Dhruvatara, or Polaris, the pole star. This itself tells us that Earth is spinning about its own axis, and the axis of Earth's spin is pointing at a direction towards the pole star. So look at the diagram carefully and take a minute to think what is happening, and particularly concentrate around this diagram. So what have we figured out? The sun is here. Of course, remember, although in this picture sun is shown to be this small, sun is many, many, many times bigger than Earth. But these are only cartoon figures, not drawn to the scale. But imagine sun is here and Earth is going almost in a circular orbit around the sun. Earth's direction, spin direction, this direction is pointing towards Polaris, or the Dhruvatara. And because the angular momentum is almost conserved, I'm using the word almost, remember. Okay? I'll come back to it shortly. Therefore, the direction of its spin angular momentum of the Earth is pointing in the same direction, while the Earth is going around the sun in almost a circular orbit. Actually an elliptical orbit, but the ellipse is, in this case, the eccentricity is not very large. So you can take Earth's orbit to be roughly circular around the sun. And because of the conservation of spin angular momentum, almost the direction of the spin axis remains the same. And that's the reason why pole star Dhruvatara doesn't change its position at all when we see the night sky throughout the year. Okay. And it is the tilt of the spin axis of the Earth with respect to the orbital plane, Earth-Sun orbital plane, which causes changes in various seasons. All right. Very often, some school textbooks give wrong reason that summer happens because Earth is closer to the sun and winter happens because Earth is far away from the sun. This is all wrong. As I said in the beginning, Earth's orbit around sun is almost a circle. So the distance doesn't change much. The reason why seasons occur is because of the tilt of Earth's axis with respect to the plane of the Earth-Sun motion. Why is it so? It can be understood qualitatively by those who are interested to a small calculation. For example, when Earth is in this position, that means northern hemisphere of our Earth is tilted towards sun, then a given solid angle, if you take a small area here, then amount of radiation within the solid angle from the northern hemisphere is much larger than take the southern hemisphere, and takes the same area, because this part is tilted away, the solid angle, the area may be same, but the solid angle is less. Therefore, the northern part, the solid angle being larger for the same area means lot of solar energy is falling on an area A, but for the southern hemisphere, for the same area covering a smaller solid angle, lesser amount of solar energy is falling there. And therefore, this part gets more heated than the southern part. Reverse happens in the winter for the northern hemisphere. That is, in this position, the northern hemisphere amount of solar energy per unit area for the northern hemisphere is less compared to amount of energy per unit area for the southern hemisphere. And that is precisely the reason when in this position the northern hemisphere has summer, the countries in the southern hemisphere like Australia, South Africa, they face winter. And the reverse is the case when Earth comes to this position. I mentioned that the axis is pointing towards Polaris or Dhruvatara now because the spin angular momentum is almost conserved. You might say that does it mean spin angular momentum is actually not conserved? The answer is that those who have studied mechanics know that in the absence of a torque, angular momentum is fully conserved. So right from our school days, we know from Newton's laws of motion, we know that if you have a body and if there is a force exerted on the body will accelerate. If there is no force, body will continue to remain either at rest or uniform motion. That means its linear momentum is conserved when the the body's linear momentum is conserved when there is no force. Linear momentum will change if there is a force acting, and rate of change of linear momentum is given by the force. And Newton's laws of motion can be also used to prove another result, namely the angular momentum is conserved if there is no torque. But if there is a torque, then rate at which angular momentum changes is given by the torque acting on the body. And now let's come back. One moment. I think there is a problem with delay of my uh, sentences and the slide. Let me pause for a while to correct the problem. One moment.
So network connection, there is an attempt to resolve. I think it is now resolved.
Am I audible now?
Yes, yes. And there's a question also.
Yeah, let me answer the question.
Question is from Dinesh Singh. Sir, here Sun and Earth between spin rotation same as like Moon and Earth rotation. If you are on your full screen, on your presentation, you may not be seeing the question. So I'm reading it out.
Dinesh, I don't understand your question. Okay, I hope Dinesh, I've answered your question because from the words it was not clear as to what you were asking. Uh, right, so let me, because I was not audible, let me once again state what I was saying regarding the Earth's axis of rotation. So, first of all, we know that today the axis of Earth's rotation, the northern part of the axis points towards the Dhruvatara or the so called pole star, or also referred to as Polaris. But it was not all the time the case. Why? Because this axis of Earth's rotation is actually precessing. Just now I mentioned that the angular momentum is conserved. That means angular momentum's magnitude and direction remains the same only when there is no torque. But if there is a torque, then angular momentum will no longer be conserved and its magnitude and direction can change. You might say that, well, what can cause the spin angular momentum of Earth to change? The answer is our closest neighbor. Which is our closest neighbor? Moon. So although Moon is not as big an object as Earth, but nevertheless it's fairly close by, and the tidal force of Moon, which causes the high tide and the low tide, we will soon see what does one mean by tidal force. Here I can only say that whenever the gravitational force due to an object depends on distance. That means there is a differential gradient in the gravitational acceleration. It will cause tidal force, and similarly, it will cause tidal torque. So, if you have moon going around the Earth, remember that moon's orbital plane is tilted with respect to the Earth-Sun orbital plane, and therefore the Earth's bulge, because Earth is spinning around its own axis, the Earth has an equatorial bulge. And since Moon's orbital plane is not in the same plane as the equatorial plane of the Earth, the Moon's differential gravity causes a torque on the Earth. And because of the torque exerted by Moon's gravity on Earth, Moon's tidal torque makes the Earth's spin axis precess about a direction. So in this slide, you can see that the Earth's axis of rotation is spinning around. And that is happening because of the tidal force, the tidal torque exerted by the moon on Earth. The precession, of course, is very slow. Today, the axis is pointing towards the pole star. After about 26,000 years, again the axis will be pointing towards the pole star. So it is a very slow rate of precession, and the angle with respect to the axis perpendicular to the Earth Sun plane, this tilt angle is about 23.5 degrees. Maintaining the same 23.5 degree tilt, the axis of Earth's rotation precesses about this line, which is a vector perpendicular to the Earth Sun plane. All right. This phenomena is called precession of the equinoxes. So today, the axis is pointing toward the pole star, but after about 13 to 14,000 years, the axis will point towards the star Vega. That means what? That future generation who will be living 14,000 years from now, for them, the Dhruva Tara will not be the Polaris, but will be the Vega star. All right. By the way, here I must mention that using the precession of Earth's axis, you can date some of the shlokas of Rigveda. You might wonder how. Now, Rigveda has a shloka which says that you start the yajna when on the day of vernal equinox, that means the spring equinox. What is an equinox? Spring equinox happens these days on March 21st. Spring equinox is a time when the length of the day is same as the length of the night. Okay? And this phenomena was known to our ancestors for a very long time. That's why the equinoxes were very important. So spring equinox, autumn equinox, 21st September, around that time was the autumn equinox. Again, go back to one of my slides. Let me go back to one of the slides to explain why these equinoxes take place. Yeah. So you can see in this picture that you have this tilt and Earth is going around Sun, and therefore consider this position where you have the northern hemisphere of the Earth is facing winter while southern hemisphere is facing summer. From the picture itself, it will be clear that during this time, the people in northern hemisphere, for them day will be shorter and night will be longer. Look at this. Very close to the North Pole, you can see this latitude. A tiny segment of the circle is in the day part, while the bigger part is in the night, showing that at this position, day for the northern hemisphere has the least duration compared to the night. So is true in the northern summer and southern winter. In northern summer, you can see that day part is longer than the night part. Again, this is happening because of the tilt of the spin axis of the Earth. But there are two positions which are very special. Look at this position. In this position, when the tilt axis, all right, is neither pointing towards sun nor pointing away, that is the time when the span of the day and span of the night is exactly the same. And it happens for the March 21st and near about September 22nd. That's why vernal equinox or the spring equinox and the autumn equinox. And equinoxes were recognized as important events by our ancestors. Let's come back to the particular hymn that I was referring to in Rig Veda. In one of the hymns, the Rigvedic seer who composed that particular shloka writes that on the early morning of the equinox, when Kritika, the constellation Kritika is in the western part, Kritika is nothing but Pleiades. Pleiades, those who have looked at the sky, there's of course Saptarishi or Ursa Major. As you know, Saptarishi has 7 stars in a plow shape, and it is called the Big Bear or Ursa Major. And similar in shape is another group of small constellation called Kritika. But Kritika has 6 stars, while Saptarishi has 7 prominent stars. There is, of course, a near Vashishta. There is a faint star called Arundhati. Vashishta's, in mythology, Arundhati is Vashishta's wife. And there is a whole story I don't want to go into as to why Kritika has 6 stars. Because 7 sisters, one of the star was kept near Vashishta, namely Arundhati. Those who are interested can read the interesting mythological story to explain why Kritika has 6 stars and why Saptarishi has 7 prominent stars named after rishis, and a small faint star near Vashishta has been called Arundhati, who is Vashishta's wife. That's an interesting story by itself. Let me not go into that story right now. But coming back to Kritika, and Kritika or the 7 sisters have been referred to in Rigveda several times. In fact, the Kartik month is named after Kritika Nakshatra. And also, Skanda or Kartik, the god of war, has an interesting story of origin related to Kritika Nakshatra. Those who are interested can study. But those are mythological stories. Let us come back to proper astronomy, because by now all of you must realize that astronomy is proper science and has nothing to do with astrology. That distinction must be kept in mind. Now, how can we date the shloka of Rigveda, where Rigveda says that on the spring equinox, when Kritika is rising at the horizon, one must set up the yajna, one must light the woods for a yajna. Okay? The surprising thing is that these days, on the vernal equinox day, it is not Kritika which rises, but it is the Aries constellation or the Mesha constellation, which rises early morning on the day of vernal equinox. So let me again reiterate what I want to say. Rigveda mentions that on the day of vernal equinox, when Kritika Nakshatra is rising in the horizon, you must light up the woods in the yajna fire so that we can carry out a yajna. While today, we certainly don't see Kritika rising on the horizon on the day of vernal equinox. What we see is Aries constellation that is rising. So you can say that, does it mean that the Vedic rishis have made an error? By the way, here I must mention, around the same time, the Chinese chronicles also mention the same thing. So clearly, the Vedic seers who composed the shloka were not wrong, because Chinese chronicles, very ancient Chinese chronicles, also mention the same thing. How can that happen? You can easily guess. It can happen because the axis of Earth's spin is precessing. And therefore, because of the precession, I have already mentioned, why does equinox takes place? Equinox takes place because the vernal and autumn equinoxes are the day when the spin axis of Earth is neither pointing towards sun nor it is pointing uh, away from the sun. It is on a plane which is parallel to the plane made by the summer and winter line of Earth's orbit around sun. Please refer to the picture and you can immediately convince yourself that vernal equinox and autumn equinox takes place exactly at the points when the spin axis of Earth, the vector, its component is zero towards the sun or away from the sun. But precession makes the spin axis change, and therefore the time of the vernal equinox will also change very slowly because the axis is precessing at a very slow rate, and one can calculate thereby when was it that Kritika constellation was rising when there was vernal equinox, and you can find out, you can do the calculation, and it turns out that it is around 3300 BC. All right. So around 3300 BC, Kritika was rising at the horizon on the day of vernal equinox. So clearly, this shloka of Rigveda, one of the oldest shloka of the Rigveda, can be dated using our modern astronomy. Okay, right. Now let's go to, we have already talked about Earth and Moon. Now let us go to other members of our solar system. So we know that apart from Earth, we have Mars, Venus, Jupiter, Saturn, Uranus. Of course, Pluto has been Plutoed. Pluto is no longer considered to be a planet, and therefore a new phrase in English called this member has been Plutoed, meaning it has been demoted. So Pluto is no longer classified as a planet, but nevertheless it's a member of our solar system. And some of the planets were known to our ancestors because they could spot them with naked eyes. So Mercury was known to ancient astronomers. Venus was known, and Venus played a very important role in our Vedic mythologies. Venus, also called Shukra, was supposedly the teacher of the Asuras, while Jupiter, which is referred to as Brihaspati, was teacher of the Devas. Now, why this classification was made, no one knows. Why is it that Venus, which is normally one of the brightest planets in the evening sky, was referred to as the teacher of the Asuras, while Brihaspati or Jupiter was the teacher, which is also a very bright planet, very often coming in the early morning and also in the evening. Perhaps the Venus appearing as a bright planet in the evening and evening or nights were sort of derogatorily referred to the Asuras, while early morning was attributed to the Devas. Maybe I'm just speculating. I don't know the real answer. Of course, these are only stories, but as they have some relevance to astronomy, I'm mentioning this. Mars or Mangal, which also captured the imagination of ancestors because of its reddish brown appearance. Today we know why Mars appears reddish brown. The reason is that the arid soil of Mars has a lot of iron oxide, and which gives it a rusty color as far as its appearance is concerned. Mars, Mercury, Earth, Venus, they are of course solid. They have a the massive portion is solid like Earth. On the other hand, gigantic planets like Jupiter, Saturn, they are gaseous planets. And our ancient ancestors had fathomed that there is a difference between bright objects like planets and bright objects like stars. Of course, the twinkling was there. Again, I would ask some of you who are interested in referring to old literature to find out whether our ancient Indian literature referred to the distinction of stars twinkling while planets not twinkling. It would be interesting exercise to find out whether there is a ancient scripture reference to stars twinkling while planets or the graha not twinkling. But there was another way that ancestors, whether they were Greeks or whether they were Indian or whether they're Chinese astronomers or they were Arab astronomers, they had figured out that although appearance wise planets and stars appear point like, but they were certainly different. The reason was that when you keep monitoring the sky, you find that constellations and stars, their apparent positions don't change. Their apparent relative positions don't change. What I mean is that if you look at the Big Bear, Ursa Major, or Saptarishi, over thousands of years, their shape has not changed much. While the planetary positions, they change over months with respect to this fixed stars. And that is the reason why in Western ancient literature, planets were named planets because planets meant wanderers or objects as those which move. On the other hand, planets were called graha in Sanskrit based literature with, I don't know what the reason is, graha means to grab. Graha is something which takes position. So perhaps because moon too wandered and moon was also put as part of Navagraha, and Rahu and Ketu, although they are fictitious objects, they were also clubbed with the Navagraha scheme. And Rahu and Ketu certainly were grabbers because they would grab sun during solar eclipse, they will grab moon during lunar eclipse as portrayed in stories. So perhaps that is the reason while all other moving objects were also called graha as grabbers. Probably Mercury, some ancient seer observed Venus, transit of Venus, where, we encountered transit of Venus not long ago, where you can see the spot, a dark spot moving across the sun. And that can be also viewed as some kind of a grabbing activity, causing a blemish to appear on sun. Perhaps because of these moving objects like planets were in Sanskrit based ancient literature were called graha or the grabbers. And they were, of course, comets. Here, I don't know whether it is visible. Some comets are also, uh, uh, although not shown exactly, asteroids have been shown, but comets also played a very, very important role in influencing the imagination of human beings. For example, in Chinese ancient astronomical records, comets are called guest stars because they are not there, but sometimes they would appear, they will become brighter, and so on. While in Indian literature, comets are referred to as Dhumaketus or simply Ketus. As I told you, that uh, the word Ketu in Old Sanskrit means a ray or beam of light, and also a tail like appearance. That is also referred uh, to by the Sanskrit word Ketu. And I had also mentioned the Puranic story of Rahu and Ketu, and the severed part of Ketu's body, which was had a tail-like appearance, was christened as Ketu because it was tail-like. And since comets, when they are in very eccentric elliptical orbits around Sun, that means what? The periastron and the apistron, they are very, very different. And hence, when they are very far away, this light objects made out of frozen carbon dioxide, frozen water, and many other such compounds, they maintain a rough spheroidal or rough shape, but when they come towards the sun, the solar wind and the solar radiation, they exert pressure on the gaseous substance, and a tail emerges which is pointing outwards, outwards from sun, and the tail-like appearance gave rise to the term Ketu for the comets in Sanskrit-based language, and also Dhumaketu because Dhuma refers to smoke, and because the tail appears smoky, therefore Dhumaketu was a common word that was used to describe comets. And many ancient seers like Parashara, Narada, then Varahamihira, they have talked about comets in the Siddhantic astronomy in uh, the Indian Sanskrit based school of astronomy. And Chinese have maintained a very huge Chinese, Japanese, Korean, they maintain a huge record of a large number of comments. We will come to this in subsequent lectures. Let's go to the next slide. This is my slide, last slide of the session. Why were planetary motions so very important for astronomy? I will not go into details now. We will go to the details later on. But just let me make a qualitative statement. It is Tycho Brahe, his very, very accurate measurement of planetary positions as they moved around the sun, which led to Kepler giving the first quantitative laws that appeared in science. Let me reiterate, this is a very important statement that I am making. The first ever mathematical law in science was a full set of laws. The first time full set of laws were expressed in a mathematical and geometric form were Kepler's laws of planetary motion. All right. And everyone, all the physics students know why are Kepler's laws, Galileo's observations were so important for physics. The reason is that Kepler's laws were what moved Newton to give his laws of gravitation. Newton, when he suddenly discovered the nature of laws of gravity, he realized that he is on the right track because he could immediately explain the three Kepler's laws. Now, I will stop for the time being. We will take it up in the next lecture. Now, I want to ask all of you, can we have the next lecture today start at 4:15 instead of 3:30? So let me ask, can we start the next lecture today at 4:15 instead of 3:30?
A new link for the next lecture will also be made and shared both here as well as through email.
Some questions. Himanshu, you have asked why Earth is spinning. The all cosmic objects that have been observed so far, they have some degree of angular speed. And this, of course, comes from initial condition. You might ask, why is it different cosmic objects, they rotate? What causes the rotation? And it is believed that most of the cosmic objects have resulted from gravitational shrinking of gaseous clouds. And gaseous clouds, they, to begin with, they have a very tiny angular velocity because of tidal torquing. The origin of angular momentum of cosmic objects are still not well known, but there are theories proposed by people like Fred Hoyle, people like Peebles, who recently received the Nobel Prize, etc. And the most popular theory to explain angular momentum is through tidal torquing of giant objects. When two giant gaseous clouds come, they are randomly moving, and when they come close to each other, because of tidal forces, they get deformed, they become elongated in along the line joining the two bodies and compressed in the line perpendicular. And because of the deformation and motion, there is a tidal torque which tends to rotate these deformed gaseous objects. This was the original idea given by Fred Hoyle. Later on, more quantitative calculations were done by Jim Peeble. And this is the most accepted theory as to why angular momentum originated in various gaseous clouds, and stars and planets were supposed to have formed due to Jeans instability, whereby large gaseous clouds they fragment, and when they fragment, obviously the angular momentum of the gaseous cloud, they share some of the angular momentum. But when the fragment pieces are large, the angular velocity would be very tiny. But when they shrink, because of the conservation of angular momentum, which says moment of inertia into angular speed must be conserved. So when it is shrinking, the moment of inertia is decreasing, and therefore the angular speed must go up. And that is the reason why compact objects they spin more rapidly than large objects. The sun is very large, its angular momentum is very large, but its spin period is much larger than Earth's spin period, because Earth is a compact object. Similarly, when a star becomes a neutron star, and where a massive star through its stellar evolution stages can become a neutron star, whereby the star shrinks to about a size of 10 kilometers. A neutron star has a star-like mass, but its size is like uh, a small city, only 10 kilometers. And neutron stars, which appear as pulsars, they spin very rapidly. Some spin at the rate of the period being as small as 0.33 seconds, like Crab pulsar. So it is again due to the conservation of angular momentum and origin of angular momentum due to tidal torquing. Uh, uh, the other statement about east to west line in horoscopes, we will not deal with it, because horoscopes, astrology, they are not part of science. So astronomy is a scientific discipline, astrology is not. And therefore, we will not make any comment on horoscopes, astrology, etc. in these set of lectures. Well, there is a question that will the afternoon lecture be of 1 hour? Well, technically, the afternoon lectures, there are two lectures in the afternoon, but if you wish, for today, we can have it for 1 hour, that is quarter past 4 to quarter past 5, because the other hour is supposed to be tutorials. So today being first lecture, there are no tutorial problems given, tutorial questions being given. So for today, we can have the afternoon lecture only of 1 hour duration. So 4:15 p.m. to 5:15 p.m. Is that all right with everyone? Okay, let me answer two other questions. Priyamvada Kameshwar has asked about differential rotation. So I had mentioned that in the case of sun, if you look at the rotational motion on the surface of the sun, you will find that the equatorial part of the sun is rotating uh, at a different rate compared to uh, the other latitudes. Now, obviously, this can happen only in a gaseous form because in solid, the solids by definition are objects where there is rigidity. So if I take an object like a stone, different parts of the stone cannot have differential motion. A object like stone can only rotate like a rigid body because it's a solid, and by definition solid different parts are frozen with respect to each other, while liquids and gaseous object, in other words fluid, the word fluid encompasses gas, liquid, and plasma phase. In such systems, because the density is um, smaller and the forces that take place between different parts of fluid is viscosity, and viscosity is not such a strong force, and therefore you could have different parts of a fluid moving with different velocity. So the differential motion is seen in the gaseous objects like stars. It is also seen in gaseous planets. Like, for example, in Jupiter, you have the red eye. Okay? So, sorry, is it Jupiter or Saturn? I've forgotten that. But the red eye that you see is a gigantic tornado that is going on, and this tornado can arise only due to a differential motion, because when you have a differential motion, that means a fluid element moving in one direction and nearby fluid element moving in the reverse direction, that constitutes a spin angular momentum, and that can give rise to a tornado. And this red eye is a gigantic tornado. This is only possible in a gaseous planet. There's another question as to yeah. So the question is about why we don't, or do we see the surface during total solar eclipse? The answer is yes, we do see the craters of the moon. In fact, the so-called the diamond ring, etc., appears because the surface of the moon is actually not smooth. There are gigantic craters. So during the eclipse, the rim of the moon being irregular can certainly be seen, but the surface which is pointing towards you uh, with naked eye, you can't see because it's too dark, and therefore you can't resolve. If you have a powerful telescope, uh, so that even there is intensity resolution available, you could see the craters that are facing you when there is a totality. That's a very good question, Priyamvada. Yes, in fact, I forgot to mention the Earth's solid crust, That means the terra firma which we encounter every day, it is that which is rotating in a solid manner. The molten liquid that geologists have inferred, the so-called the core molten iron liquid, which is responsible for the geomagnetic fields, that has differential rotation. In fact, um, the shift in the magnetic poles of Earth is partly due to the differential motion of the molten liquid compared to the rigid body rotation of the solid part of the Earth's crust. So, thanks for asking, Priyamada. It's a good question. Yeah, Shubham, your question as to if there was no moon, then what could have happened? If there were no moon, first of all, no high tide, or rather, high tide and low tide intensity will be smaller, because the high tide and the low tide are caused not only by moon's tidal gravity, but also due to sun's tidal gravity. Again, what is this tidal force? If gravity was completely uniform, that means gravitational acceleration has the same magnitude and direction everywhere, then there is no gradient of gravity, right? Because the derivative of the gravitational field will be zero everywhere. But sun's gravity, moon's gravity, they are not uniform. They follow, because they are almost spherical in shape, the magnitude of sun's gravity and moon's gravity fall off as 1 over distance square. So therefore, points which are close to sun would get attracted more than the points which are far away from sun. And that is what causes the tidal force, meaning objects get stretched in the direction towards the sun and gets compressed in the direction perpendicular to this uh, the radial direction. This is what is the tidal force. And if moon was not there, the tidal high tides and the low tide will not be as strong as today we see. For example, uh, on a full moon day, you will find, particularly when you're seeing the full moon on the uh, zenith, you will find that the tides, if you have lived in a coastal region, you will see that the tides are really very high, because both sun's tidal force and moon's tidal force, they act coherently. In fact, during the eclipses, they are much more coherent than other times, and the tidal forces, they um, sort of uh, sum up in a coherent manner, and high tide and low tides are much more intense. So if there was no moon, then no high tide, no low tide, and because of that, Earth's spin angular momentum will not change, and therefore no precession also. If there's no moon, there is no precession of the equinox. All right. And I would say the following is not part of science. If there was no moon, many of our literature will not take place, because the phases of moon and the Purnima or the full moon have inspired beautiful poetries and beautiful literature since ancient times. So if moon was not there, we would uh, be poorer by the exquisite literature that exists. Yeah, good question as to why, to begin with, uh, there is a tilt of the Earth's rotation axis. That means, why is the axis of rotation of Earth not perpendicular to the plane of the Sun and Earth orbital motion? Again, this is due to initial condition of formation of Sun and the planets. It is believed that a single huge cloud that was rotating, as it shrunk gravitationally, and there was uh, Jeans instability, the core formed the star, and then there was a uh, dust cloud forming a disk around the newly formed proto-sun, and it is this dust disk around the sun that over billions of years the dust particle condensed and formed different planets. And while they were condensing, different tidal torquing would have resulted in angular momentum being different from the orbital angular momentum of the dust ring around the sun. So essentially, it is the initial condition while formation of planets were taking place, which sort of decided what was the spin angular momentum. Also, it could be that later on, I mean, it might be that initially the Earth's spin axis was perpendicular to the Sun Earth orbital plane. That means Earth's orbital angular velocity vector and spin angular velocity, maybe in the beginning, was in the same direction, but a giant object, giant asteroid, might have come by very close to the Earth, and its tidal force, tidal torquing, might have changed the direction. That could have also been possible. After all, the formation of moon is also attributed to the collision, a close encounter of a giant body when it came close to the Earth. So such perturbation could have also changed the original angular momentum, spin angular momentum direction of Earth. So good question, Premvada. Are there any questions?
There don't seem to be any further, and perhaps we could end the broadcast now.
All right. Thank you for joining us for the morning session. So our next session will start at 4:15, and we will soon send you the link for the session. All right. Okay. So take care and